This video is on drawing Lewis structures. And when we're drawing Lewis structures, there's about 5 steps that you have to follow in order to draw a Lewis structure correctly. Now, what we're going to do is we're going to practice on drawing Lewis structures by using 4 different compounds. So we're going to do each one at a time. And instead of writing down all the rules, it would be helpful if we follow the rules as we go along, and you'll kind of get the hang of it that way. Now, the first thing that you should do is you should determine the total amount of valence electrons. And if you can't determine the valence electrons, then you need to go back and look at the video that deals with determining the number of valence electrons an atom has. But we're going to look at CH4 first. Now from the carbon atom, because carbon is in group 4A, it has 4 valence electrons. And hydrogen is in group 1A, and it has 1 valence electron. However, we have 4 hydrogens, so we need to multiply the 1 times 4. So the total amount of valence electrons is 8 valence electrons. Now the second thing we must do is find the central atom. The central atom is usually the least electronegative atom, except hydrogen. Hydrogen will never be a central atom. That is a common error that most students make. So write it down in big bold letters that hydrogen will never be a central atom. So since we're doing CH4 and we know that hydrogen will not be a central atom, carbon must be our central atom. So carbon, I'm going to write in here carbon as the central atom. Now the next thing we're going to do is we're going to determine the layout of our structure. And generally, how the condensed form of the structure is written kind of tells you how it's drawn. Meaning that the atoms that are next to each other in the formula will usually be bonded together. So since carbon is next to 4 hydrogens, then carbon must be bonded to these 4 hydrogens. So we're going to write this out. Doesn't matter where you place the hydrogens around the carbon as long as the 4 hydrogens are around that carbon. Now, afterwards, you're going to connect each atom, and you're going to connect it to that central atom using a line, one single line. Now, each line represents 2 electrons. Now, the valence electrons tells us the maximum amount of electrons that that particular molecule has. So, we cannot use more than 8 electrons. We can't use any more or any less. So, since we already used up some electrons, we must subtract that from the total amount of valence electrons. So we start off with 8 valence electrons, and I'm going to subtract it from the total amount of valence electrons. From the amount of valence electrons, that I've used. 2, 4, 6, 8. So that leaves me with 0 electrons. So this is the total amount that I have, and this is how many I've used. So therefore I have 0 valence electrons left. Now, the next thing I'm going to do is go back and I'm going to make sure that each atom obeys the octet rule. Now every atom should obey the octet rule except hydrogen. Now there are some exceptions to that rule, but right now we're really not going to deal with those exceptions. Now, so I'm going to make sure that every atom, and you can write this down, except hydrogen obeys the octet rule. So here, carbon has 2, 4, 6, 8 electrons around it. So since it has 8 electrons around it, it obeys the octet rule. I've used up all my electrons, so therefore, this is the structure of methane, or CH4. Now let's try another one. Let's try another one. I'm going to add in a structure. Let's try CBr4. We're going to try carbon tetrabromide. So the first thing that we're going to do is we're going to count up the total amount of valence electrons. Carbon has 4. Bromine has 7 because it's in group 7A, but we have 4 of them. So 7 times 4 is 28. 28 plus 4 is 32. So we have 32 valence electrons. Now we're going to determine the central atom. And our central atom in this case will be carbon. So I'm going to write down C for carbon. Now I'm going to determine the layout of my structure. I know that carbon in my formula is next to 4 bromines. So I'm going to just lay this design out, and I'm going to have carbon next to 4 bromines. Next to those 4 bromines. Now I'm going to connect each atom using a single line. So I'm going to connect each atom to that central atom using a single line. And afterwards, I'm going to make sure each atom obeys the octet rule, except hydrogen. But we don't have to really worry about hydrogen because we don't have any hydrogens in here, just bromines. So if I take a look at carbon, carbon has 2, 4, 6, 8 electrons around it, so it obeys the octet rule. Let's take a look at bromine. It has 2, and so it needs 8 electrons around it. It only has 2 around it. So how do we deal with this problem? Do we go in and write double bonds, triple bonds, long pairs of electrons? Well, this is how you figure it out. First, try making your atom obey the octet rules by using long pairs of electrons. If your long pairs of electrons run out, meaning you have used 32 valence electrons, then you go in and make double bonds. If you can't make everything obey the octet rule by using double bonds, then you go in and you use triple bonds. But we haven't started using long pairs first. So we're going to start trying to make everything obey the octet rule by first using long pairs. So before I do that, I'm going to see how many electrons I have left to use. I started off with 32 valence electrons, but I've used up 2, 4, 6, 8 of those electrons. So I'm going to subtract 8 from that. So when I subtract 8 from that, that leaves me with 24 valence electrons. So now I'm going to go in and put in my lone pairs. So bromine has 2 already around it, 4, 6, 8. So I've used up 6 electrons from the 24 that was left over. So now I am left over with 16. No, not 16, sorry, bad math, 18. 18 valence electrons. So I can go in, I have 2, 4, 6, 8. So I've used up 6 more. So I'm going to go ahead and subtract the 6 from here, and that leaves me with 12 valence electrons. This bromine has 2 around it, 4, 6, 8. So I've used up 6 electrons. So that leaves me with 6 valence electrons. So I go up here and I have 2, 4, 6, 8. And so now I used up my last 6 valence electrons, and I'm left with 0. So now since I'm left with 0 electrons, I don't have any more that I can use. However, everything obeys the octet rule. So therefore, this is my Lewis structure for carbon tetrabromide. All right, so we have 2 off of our list that's done. Let's go in and look at another one. So we're going to look at CH2O. So the first thing we're going to do is we're going to determine the total amount of valence electrons. Carbon has 4 valence electrons. Hydrogen has 1 valence electron, but we have 2 hydrogens. And the last we have oxygen. Oxygen has 6 valence electrons. So if we add them all together, we get a total amount of 12 valence electrons. Okay, so now that we have 12 valence electrons, we're going to determine the central atom, which we know is usually the least electronegative atom. And here, the central atom will be carbon because hydrogen will never be a central atom. So I'm going to write in carbon as my central atom. Now I'm going to determine the layout of my structure. Well, carbon is next to hydrogen, and hydrogen is also next to oxygen. However, I know that hydrogen can only make 1 bond because it has 1 valence electron. So, since hydrogen can only make 1 bond, hydrogen must be bonded to my carbon. If hydrogen was bonded to my oxygen, it's usually written over on the other side to clearly state that the hydrogen is bonded to the oxygen. So, I know that the hydrogen must be bonded to the carbon, and the oxygen must also be bonded to the carbon because it cannot be bonded to the hydrogen because hydrogen only makes that 1 bond. So now I'm going to connect each atom using a single line. So I'm going to connect everything to the central atom using a single line. And now I'm going to subtract the number of electrons that I've already used from the total amount of valence electrons. So I started off with 12 total valence electrons, and I've used up 2, 4, 6 of them. So I'm left over with 6 valence electrons. So the last thing I'm going to do is make sure that each atom obeys the octet rule. So let's try carbon first. We have 2, 4, 6 electrons around carbon, but we need 8. So the first thing we're going to do is try to make sure that every atom obeys the octet rule by first using lone pairs. So I have 2, 4, 6, and I'm going to write in 8. So I've used up 2 additional electrons, and so I'm left with 4. Now with oxygen, it has 2 around here, 4, 6, but I only have 4 to use, so I can't put that extra pair of electrons on because I am done. I only have 4 to go. So now I've tried to make everything obey the octet rule by using lone pairs. First, carbon obeys the octet rule, but oxygen do not. So that's kind of a problem here. So since I've used up all my lone pairs of electrons, now I'm going to go to double bonds. Now, where do I get the electrons to create a double bond. Do I get it from the carbon or from the oxygen? Well, oxygen is already missing some electrons, so I don't want to take more from it. The good idea is to take it from something that is not electron deficient, which is carbon. So I'm going to take the electrons away from carbon and say, well, instead of us just sharing these 2 electrons, let us share 4. So all of us can obey the octet rule. So if we look here for carbon, it has 2, 4, 6, 8 electrons, and oxygen has 2, 4, 6, 8 electrons around it as well. Alright, so this is an example of how molecules form double bonds or have double bonds. And let's take a look. We have this one down now. Let's try the next one. We're going to try HCN. So we're going to start up at the top. We're going to count the total amount of valence electrons. So I would encourage you to kind of pause the video and count the total amount of valence electrons and then unpause it to see if you have the correct answer. Okay, so hydrogen has 1 valence electron, so we're going to write a 1 here. Carbon has 4 valence electrons, so we're going to write a 4 here. And nitrogen has 5 valence electrons, so we're going to write a 5 here. And the total amount of valence electron is 10. So the next thing we're going to do is we're going to determine the central atom. And the central atom is usually the least electronegative atom except hydrogen. So therefore carbon will be our central atom. Now, because of the way the structure is written, we kind of know the layout of our structure. We have hydrogen bonded to carbon, which is also bonded to nitrogen. So we're going to go in and we're going to connect each atom using a single line. And so I'm going to subtract the amount of electrons that I've used from the total amount, the amount that's available to me. So I have 10 electrons and I've used up 4. So that leaves me with 6 valence electrons. Now, knowing the layout of our structure and knowing that we've used already 4 electrons, what you should do is try to pause the video and figure out the Lewis structure of the molecule, and then come back, unpause the video, and see if you have the correct structure. Okay, so let's take a look. So now we're going to try to make sure that each atom obeys the octet rule. So we're first going to have to use our lone pair of electrons. We have 6 available to us. So with carbon, we already have 2, 4, 6, 8. So we've used up 4 of these valence electrons to make carbon obey the octet rule. And we have 2 left over. So for nitrogen, we have 2, 4. And we can't make it obey the octet rule by using lone pairs of electrons because we've run out of electrons. So we've used the first rule. So the second rule we can kick into effect. We can use a double bond. Now we're going to take the lone pairs to make the double bond from the electron rich part, which will be our carbon. So we're going to take 2 of these electrons and then make a double bond in here. So we've taken 2 electrons, made that double bond. So carbon obeys the octet rule because it has 2, 4, 6, 8 electrons around it. But nitrogen only has 2, 4, 6 electrons around it. So nitrogen still do not obey the octet rule. So we hit it with a double bond. So next, we can try the triple bond. So trying the triple bond may work. So we're going to take 2 electrons, but still from the electron-rich carbon, and make that triple bond in. So let's see if everything obeys the octet rule. So for carbon, it has 2, 4, 6, 8 electrons around it. And for nitrogen, it has 2, 4, 6, 8 electrons around it. So everything obeys the octet rule. So this is the structure for hydrogen cyanide. Now, hopefully when you pause, or if you pause the video, you got this one correct. But if not, practice on the next one. Now the next one is a little bit more complicated. But if you use the same rules, you can figure it out. So let me erase everything. And let's go on to the last one, which poses a little bit more complexity. Okay, so we're going to draw the Lewis structure for acetic acid. Now I'm going to warn you, for those who are fairly good with drawing Lewis structures, the first way that I'm going to draw it will be incorrect. And the reason why I'm going to draw it incorrect is to kind of bring a point home. And then afterwards, I'm going to draw it correctly. So, first out, we're going to determine the total amount of valence electrons. So, carbon, let's take a look. So, carbon has 4 valence electrons. And we have 2 of them, so I'm going to multiply that times 2. We have oxygen. Oxygen has 6 valence electrons, and we have 2 of those. And hydrogen has 1 valence electron, but we have 4 of those. So if we add everything up, we would have 4 times 2, which is 8. 8 plus 4 is 12. And 12 plus 12 is 24 total valence electrons that our molecule has. So the central atom will be the least electronegative atom, which would be carbon. So we'll just use carbon as our central atom. And so now we're going to determine kind of the layout of our structure. So if you remember, the way things are written is usually the way they're put together. So let's take a look. So we have carbon here, and it's next to 3 hydrogens. So the carbon must be bonded to 3 hydrogens. Although these hydrogens is adjacent to the next carbon, we know that it can only be bonded to the first carbon because hydrogen can only make 1 bond. Now carbon is bonded to the next carbon. And it says that this carbon is next to an oxygen, which is also next to an oxygen, which is next to a hydrogen. So let's go back, and we're going to go back and we're going to connect each atom using a single line. So we're going to connect each atom using a single line. Now that I've connected each atom using a single line, I'm going to subtract it from the total amount of valence electrons. So I have 24 valence electrons, and I've used up 2, 4, 6, 8, 10, 12, 14. So that leaves me with 10 valence electrons. So now I need to go in and make sure that everything obeys the octet rule, but first by using lone pairs of electrons. So if I take a look at carbon, carbon has 2, 4, 6, 8 electrons around it, so it obeys the octet rule. this carbon has 2 4 electrons around it. So I need 6 8. So I've used up 4 extra electrons, so that leaves me with 6. Two, 4, 6, 8, 10, 12, 14. All right. So next thing with oxygen, I have 2 4, 6, 8. So I've used up 4 electrons. So now that leaves me with 2. And so now 2 4. 4 6. Sorry. So this oxygen has 2 4 6 electrons around it. So therefore, I'm missing some electrons because it doesn't obey the octet rule. So the second thing it says is to go in and create a double bond. So I'm going to take from the electron-rich oxygen and create this double bond. Now, this will give you the illusion, because everything obeys the octet rule, that this is the correct structure for acetic acid. But it is not the correct structure for acetic acid. The first way we could tell that it's not the correct structure is that oxygen tends to make 2 bonds because it's in group 6. And carbon tends to make 4 bonds because it's in group 4. So here we have carbon making 2 bonds here and oxygen making 3 bonds here. So that indicates to us that something must be wrong with my structure. Also, if I go in and place in formal charges. So for carbon, carbon is in group 4A, but it owns 1, 2, 3, 4, 5, 6 electrons. So this carbon has a 2+ charge. If I go in for this oxygen, oxygen has 6 valence electrons, but it owns 1, 2, 3, 4, 5. So therefore, this would have a 1+ charge. And if I go here, oxygen is in group 6 and it owns 1, 2, 3, 4, 5. So this would also have a 1+ charge. So because this guy you can look at the formal charges of this guy and tell that this cannot be the structure. I have 3 electron deficient atoms right next to each, this is electron rich, sorry. 4 minus 6, 2 negative. So here I have 2 electron deficient atoms right next to each other. So this indicates to me that this is not the correct structure of acetic acid, that it must be placed together incorrectly. So I'm going to go back and I'm going to restructure this part. So now instead of the oxygens being bonded together, what if my oxygens were bonded to the carbon, or should be bonded to the carbon? And because this oxygen is right directly next to the hydrogen, it's on the other side, I know that the oxygen must be connected to the hydrogen. So now let's go back and do this all again. We know that we have 24 valence electrons. Let's see how many have been used up. We have 2, 4, 10, 12, 14 electrons that we've used up already. So that leaves us with 10 valence electrons. So now we're going to go back and try to make sure that everything obeys the octet rule. First, we're going to use lone pairs of electrons. So for this carbon, we have 2, 4, 6, and we're going to put in 2 electrons to get it to obey the octet rule. So we've used up 2. And we're left over with 8 valence electrons. Here we have 2, 4, 6 electrons. Sorry, my mind's bad. Here we have 2 4 electrons, so we're going to do 6 8, and we're left with 4 valence electrons. And here we can do 2 4 6, but I've used up all of my 4 valence electrons. So now I can go back because I've used up all my valence electrons, but oxygen is still electron deficient. So the second thing I'm going to do is draw in a double bond. And I'm going to take these electrons from the electron-rich carbon and place in a double bond. Now, this is the structure of acetic acid. Now, to really get the hang of drawing Lewis structures, you have to draw lots and lots of them. Once you begin to draw lots and lots of Lewis structures, you will kind of figure out where the double bonds and the single bonds and the lone pair goes. So you need to practice, practice, practice. So go on in Canvas, download the worksheets, and practice, practice, practice.